Hey everybody, this is Larry. This is day 5 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about uh, today's problem. Remove duplicate from sorted list 2. Um, yeah, so I usually solve and explain these problems live, so if it's a little bit slow for you, feel free to fast forward or skip ahead or watch another video. Okay, so it's just removing duplicates except for that this is a linked list instead of a like an array list or something like that. And it's because it's sorted. It should be straightforward. Oh wait, no. Hmm. Oh, so you remove all instances where there's duplicates, not just okay. Because so I thought you just remove only the duplicates until it's distinct. That would have been slightly easier. I mean, it should still be the same, um, but not a big deal. Um, yeah, okay, it's okay. So my thing was that yeah, if you only remove like the second and the third instance of the value, then it becomes a little bit easier, just because of the pointers. But I think once again, this is a linked list problem. Um, I don't think there's anything tricky about this other at least in algorithm. I think all the trickiness is in implementation. So definitely, as I always say, just do it on paper and make sure that all your pointers are where you think it should be, and let's get started. I think. So yeah, so the way that I always do these is to kind of create my own head node. And then current is your new head, and then just for each node that is so if a node is equal to its next node, then um, we don't uh, we don't add it to the current head. So I think that's mostly how I'm going to write it. So while head is not none, um, and then have something like hmm, so there are a couple of cases that I'm thinking in my head. So okay, so if head dot value is equal to head dot next dot value, we'll obviously also have to check this for none. So yeah, so if head dot next is not none and this thing, then we can skip ahead, right? And right now we're using head as the pointer as well. So we do something like head is equal to head dot next. But then now we have to think about, with the odd number of them, then that's not cool. So here we do a while loop, but hmm, yeah, okay. I think what I want to do is okay. Let's just say original is equal to head, and then while that next and this thing original dot value, then head is equal to head dot next. So this basically just have a two pointer system where okay, this is the beginning of the node. The head dot next is yeah, let me just create more pointers. I think it's easy to kind of mix up where I want it to be. So yeah, so now we want a 2 point algorithm. One is on the beginning of that linked list. Second one is just to walk how many are duplicates, right? So let's go to possible dupe is equal to head as well. So okay, so while possible dupe is not none and original dot value is equal to possible dupe dot value, possible dupe is equal to possible dupe dot next. So this basically just keeps on moving while it's the same as the first element. Um, and then now, if original is equal to possible dupe, that means that we have not moved at all. Then we can actually add this to the current linked list. So we're gonna do that, and yeah, and then we move the current head. and then current is 0 current dot next. And then else, that means that there's a dupe. If there's a dupe, what does that mean, right? Well, that means that we don't want to add anything to the current at all. So then we can just skip this, kind of. Well, now we have to kind of do head is equal to possible dupe dot next, because now it's the last. You want to make it skip all the possible dupes, right? Um, well, I think this actually it's just possible dupes, because possible dupe would be the first, as a result of this invariant. I know I'm explaining a little bit terribly. As an invariant, this gets up the loop when possible dupe is no longer equal to the original. So then basically we want the head to be the first element that is not the same as the previous head, right? So we change it to this. And I think that should be maybe okay. And then we return new head dot next. Let me run it real quick just to kind of get a feel for it. Right now, to be honest, I'm not super confident about it, but excuse me. Yeah, okay. Well, that's not so good. Hmm, hmm. Well, that means that this never triggered. Hmm. And usually when you see something like this, that means that one of your invariants are well. And the easiest way to do it, the way that I do it, is either using a debugger if you're using an actual IDE, or here maybe I just use a print statement. Yeah, and I think I'm going to do that. I'm surprised I don't even get one element. So that means that I probably just have something silly wrong, to be honest. Yeah. Okay, so let's go for it. So head is head. Okay. I think this should be true. Let's see. Let's take a quick look. I've been using F strings a lot, or a little bit more, maybe not a lot. Thanks for the viewers for the suggestion. But yeah, but this is just Python and the auto quotes, and just kind of see what's going on. Okay, so the first pointer is 1, and then the possible dupe is next. Oh yeah, okay. I'm just being silly. Because we said that possible dupe would be the first element that is not equal to original. I think my naming is just terrible. So maybe just call it next, not dupe, next pointer. I don't know. I think that naming confused me a little bit. Um, and then now, because we know that this is always going to be different from here, we actually want, what we want to say is if original that next is equal to next pointer. Then we could add the original. Oops, that possible. Oops. Don't. Then now I'm more confident, but now I think I worry a little bit about the last pointer, because if this is none, and I mean then there'll be both equals to none. But I don't know if that gets tested correctly for because none equalness or none equal truthiness is always a little bit sketch for me. But let's do one more edge case, and then I mean it looks good, so I'm gonna give it a submit, and then let's see. Ooh, wrong answer. Oh yeah, as I was saying, that's why I said. That's why I was a little bit worried about the last pointer stuff. Because here, original dot next should be not. Oh wait. Hmm. Original dot next is not none, and next pointer is none. But that's actually interesting. Let's see what. Uh, let's see what this is at this state. So initially it's 1, you add the 1, and then 2, it should be good. Original.next. So original.next is this, it's going to be this node, but next pointer is nodes. Then why does, oh, head is equal to next point? Yeah, so then head is equal to none. So then why, how did we, oh, I see. I see, because we don't get, okay. So that's actually not with respect to this thing, is that, and I thought about this while coding it, so I'm a little bit sloppy, is that, it's that I don't set this to none. This should actually be, after we set this, we should set this next is equal to none, because right now it's a lingering thing where it, and very often sometimes if you look how I do it, that's why sometimes I create new pointers or new nodes. But in this case, I think I just want to do it in place, more explicitly, and then now you have to set the current node to none to make sure that's the case, because otherwise, yeah. All right, let's give it a submit. So I think ideally we want to test on the previous test cases, but yeah. So this time I know that yesterday, for example, I created a new list, which is why and the reason why I create new lists is so that stuff like this don't happen, because it's very explicit or implicit maybe on how we handle like the edge cases. But here, because we're changing it, changing the input directly, you have to do things like resetting the variables and stuff like that of the nodes. But yeah, otherwise, this is a linear time algorithm. The extra space, we only have a couple of pointers for the nodes, and it's linear even though we have 2 while loops. Is because this will only happen for each node once, the second while loop, and so is the output, right? Because you have 2 pointers, you move the pointer to the right a couple of times, and then the big pointer, the outside pointer, will also go to the right a couple of times. So there's no the 2 while loops act independent of each other, and this is why this is linear. You look at each node a constant number of time. That's why I have this problem. A little bit tired today, so hope that's okay. Hope everyone's doing well, and I will see y'all tomorrow. Bye bye.